Hello students, we are going to study acids. Okay, so what are acid? Acid किसे कहते हैं? Water acid. They are sour in taste and they turn blue litmus red, isn't it? This you have learned it. Okay, now acids are of two types according to their occurrence. Okay, inorganic acid and organic acid. Okay, when I am saying organic, this word means it is obtained from what? Living organisms or living things. Okay, inorganic, it is synthetically made or it is made, it is not found from the living things. Okay, like if I am saying inorganic acid, it can be hydrochloric acid, it can be nitric acid. Okay, these all are what? Inorganic acids. H2SO4, these are common names which you all know. Okay, now organic acids are like acetic acid. Okay, natural source is from vinegar, sirka. Okay, now lactic acid you can see in the sour milk, it is found. Okay, malic acid, it is found in apples. Butyric acid, it is found in rancid butter. What is rancid butter? Okay, the butter in which oxidation has taken place is known as what? Rancid butter. Okay, now citric acid is found in citrus fruits, tartaric acid in tamarind, grapes. Okay, then formic acid you can say it is found in what? Ant sting. Formic acid is found even in the bee sting. This formic acid is found. Okay, oxalic acid is found in what? Tomatoes. Okay, so these, when we are seeing tomatoes are what? Organic in nature. It is obtained from what? Plants, which is a living thing, isn't it? Now, so according to the occurrence, two types of acids, inorganic and organic. But when we talk about how much amount of acid is present, okay, so in that we will see that acids are of two types, concentrated and dilute. So we will not say two types. Acids are made in dilute form or it is in concentrated form. Okay, when we are saying dilute form, it means what? In that the portion of water is more and acid is less. And when we are saying a concentrated acid, in that the portion of the ratio of water is very less and that acid is pure. And if I say 98% HNO3, it means what? 98% HNO3 is there, only 2% of water is added to it. Okay, likewise if I say 40% HCl, 40% hydrochloric acid, it means what? That consists of 60% of water and 40% of what? That acid. So that is a dilute acid. Okay, it has been diluted, the acid has been diluted. So if we are seeing this concentrated acid, they are very dangerous because the proportion of acid in that is too high. What happens if it falls on the skin? It burns the skin also. Okay, even the skin comes out at that time, it falls on the skin. Okay, so concentrated acid is very dangerous in nature. Okay, as it consists of pure acid and very less amount of water is there. Now properties of acids. Okay, first we are going to study what? Physical properties. Okay, what we are going to study? Physical properties. So here in physical properties we will be studying what? Taste. Okay, so what is the taste of acid? They are sour in taste. Have you tasted HCl or HNO3? We can't taste it, isn't it? Why? Because they are too corrosive in nature. Even it falls on the skin, it will burn. So I'm not talking about that. But yes, in general, what? Acids are sour in taste. Okay. Now, how are they? In which form they exist in the nature? They exist in the form of solid or in the form of liquid. Oxalic acid, you can see good example. It exists in the solid form. Okay, liquid, many you have seen, lemon juice, citrus acid and all. Okay, so acids exist in the what? Solid or in liquid form at room temperature. Okay, now yes, if we talk about the litmus, it changes blue litmus to red. Okay, and the last point is it can conduct electricity. It means what? How why they are conducting electricity? Acids are conducting electricity because you can see here HCl. If I am saying HCl in the aqueous form, okay, in the aqueous form, it will dissociate into what? H plus plus Cl minus ions, isn't it? So here what happens? Ions are present, and this is the reason why they can conduct electricity. And now we are going to study what? The chemical properties of acids. Now chemical properties of acids. Okay, so chemical properties of acids, how acid reacts with metal, what they give out. It reacts with metals to give out hydrogen gas. Okay, how metal carbonate reacts with acid, how metal hydrogen carbonate react with acid, how acid react with base, and how acid react with metallic oxides. These are the chemical properties. We have to study these chemical reactions. Okay, so first is how metal reacts with an acid. Okay, so whenever a metal reacts with acid, it forms metal, salt and hydrogen gas. Okay, so one example I have given you, zinc plus HCl. It gives what? Zinc chloride plus H2. This zinc chloride will be in the form of aqueous form, and this will be in the form of gaseous form. Okay, so here you can also take example of Zn plus H2SO4. Okay, in this you will take dilute only. Okay, you will get what? ZnSO4 plus H2. Okay, so what happens? We are seeing that it reacts with metals, reacts with what? Acids to form what? The corresponding metal salt, and what? Hydrogen gas is liberated out. So when we are talking about these metals, okay, in the previous class I have said to you about reactivity series. So here reaction also with the acid depends upon what the reactivity series. Like if we are taking sodium, if we are taking magnesium, their reaction will be more vigorous than what? Zinc. Okay, the more the reactive the metal is, the more the vigorous the reaction will be. Okay, now when we are talking about silver, gold, what will happen? They will not react with the acid to give what? Hydrogen gas. So depending upon the reactivity of the metal, they will react with the acid to give hydrogen gas. Metals like silver, gold and all will not react with acid to give hydrogen gas because they come below hydrogen in the reactivity series. Okay, now next, metal carbonate reacts with acid to give metal salt, water and carbon dioxide. Okay, so remember here, whenever a carbonate or hydrogen carbonate is taken, what gas will be evolved? Carbon dioxide. Okay, so here if metal carbonate, for example, I have taken what? Sodium carbonate and reacted with hydrochloric acid, we are getting what? Sodium chloride plus water plus CO2 is given out. This will be in the aqueous form, this will be in the liquid form. Okay, so here you can see which gas is liberated? Carbon dioxide. Okay, you can also take an example of calcium carbonate CaCO3 plus H2SO4. Okay, in this also you will see what you will get: CaSO4 plus H2O plus CO2. Okay, so this carbon dioxide is liberated. Again, if we are taking a metal hydrogen carbonate, for example, I have taken here what? Sodium hydrogen carbonate and reacting with an acid. Okay, the acid taken over here is hydrochloric acid. So what will be formed? Sodium chloride will be formed, okay, which will be in the aqueous form, and water will be in there in the liquid form, and carbon dioxide will be liberated. When I am saying aqueous, you all know that this with the, along with this salt, what water is present. Okay, now so here you are seeing what? Carbon dioxide is being released out. How can we test the presence of carbon dioxide? Okay, carbon dioxide, the best test is when we pass this carbon dioxide in lime water, it turns what? Milky in nature. So if I am saying that it turns milky in nature, why does it turn milky in nature? Something might have reaction have taken place, isn't it? So it has turned what? Milky in nature, isn't it? So we will be passing what? Carbon dioxide, what? Lime water. Okay. So what is lime water? Calcium hydroxide, CaOH whole twice plus CO2. Okay. We are passing this in what? Calcium hydroxide. What we are getting is, we will be getting CaCO3. Okay, this PPT makes that lime water what? Milky in nature. And what we will be getting? We will be getting water. Okay, so if you balance it, okay, calcium is 1, isn't it? Simple hit and trial method we will be using. Calcium 1, okay, then balance what? Carbon, carbon is also 1. Oxygen, oxygen is 4 over here, 2 plus 2, 4, here 3 plus 1, 4, and hydrogen is 2. So it is balanced already. Okay, so what happens in this? Due to formation of calcium carbonate, what happens? This lime water changes what? Milky in nature. This is what? Lime water. Okay, this is calcium carbonate. Okay, and one thing, if you go on passing carbon dioxide, okay, CaCO3 has been formed, and if you go on passing what? Carbon dioxide, what will happen? More and more carbon dioxide is still passed after the formation of calcium carbonate also. So now what will happen here, if more and more carbon dioxide is passed, here water is also there, you can see, isn't it? So it will form what? Calcium hydrogen what? Carbonate. Okay, CaHCO3 whole twice. So now the next chemical reaction. Okay, acid reacts with base to form what? Salt and water. Okay, here actually this acid and base both react with each other and nullify the effect, and as the result a neutral substance, which is what? Salt, will be formed. Okay, plus water. But this salt can be acidic or basic also, depending if we are using a strong acid or a strong base, okay, or we are using a weak acid and a strong base, or this weak base or a strong acid. Accordingly the salt will be formed. For example, if we are taking HCl and if we are taking NaOH, both are strong in nature. HCl, hydrochloric acid, is also a strong acid, and sodium hydroxide is a strong base. Both will react and they will nullify the effect of each other, and as the result a neutral salt will be formed. Okay, that is what? NaCl plus water. But next we are seeing, we have taken H2CO3 in aqueous form. This is carbonic acid and this is a weak acid, and but the base we have used is a strong base, KOH, potassium hydroxide, and as the result what will happen? These two will react, and naturally you will see what? If we have taken this strong base and weak acid, this salt which will be formed will be a basic salt. Okay, and water will be given, okay, out. Next we have taken what? H2SO4. This is a strong acid, okay, and NH4OH is a weak base. Naturally what will happen? They both will react, neutralization will take place to a certain extent, but as we have taken strong acid, what will happen? We will get a acidic salt, that is NH4 whole twice SO4 is a acidic salt plus water. How this acidic and basic is coming, you can understand. If the acid used is weak and base used is strong, okay, we will get a basic salt. If the acid used is strong and base used is weak, we will be getting a acidic salt. And if yes, both are of equal strength, we will be getting a neutral salt. Okay, now next, metal oxide plus acid, it gives salt and water. Actually what happens? Metal oxides are basic in nature. Okay, as the result, it also behaves as a base. So when it acts with acid, it forms salt and water. So example, we have taken copper oxide reacts with hydrochloric acid to give what? Copper chloride plus what? Water. This copper chloride you are getting, which is what? Blue green in color. Okay, if you are taking sodium oxide reacting with what? Hydrochloric acid, you will be getting what? In this, you will be getting what? Sodium chloride plus water. Okay, so here also you are seeing what? You have taken what? This is a strong base, Na2O, isn't it? And here HCl is a strong acid, neutralizes to give a neutral salt and water. So this is all about the chemical properties of acid. So today we have studied what? Organic, inorganic acid, concentrated and dilute acid, okay, and physical properties of acid and chemical properties of acid. So this is all for today. Take care. Good day.